Welcome back to the MRM Study Circle. Today I am going to explain a simple way to remember the bond order, bond length, bond dissociation energy and magnetic nature of homoatomic molecules related to the molecular orbital theory. Look at the table. Only homoatomic molecules, ions given in the table. Bond order, magnetic nature of homoatomic molecule, ions only. There is no heteroatomic molecule in the table. So here there is 20 electrons, total number of electron in the table. There is 10 atom and ions is given, and the bond order given, and magnetic nature is given. So here, bond order is not more than 1 up to 8 electrons. See, 1 electron in the molecule, bond order 0.5, 2 electron 1, and 3.5, 4, 0, 5, 5.5, 6, 1, 7.5, 8, 0. Bond order increasing from 9th electron onwards. See, bond number of electron 9, bond order 0.5, and 10 1, 1.5 2, 2.3, 2.5 and 3. So maximum bond order 3, that is a total number of electron 14. This is the 3 electron is given, and the bond order decreasing after the 14th electrons. See, 15th electron 2.5, 2, 1.5, 1.5, 0. See, the bond order increasing from 9th electron to 14th electron and then decreasing. See here, bond order 0. So that number of electron 2, then 4, then 8 electron, then 20 electrons. See here, 4th electron, not 2 electron, 4, 0, then 8, 0, then 20 electron 0. See, bond order 0, 1, 2, 3 are diamagnetic nature except boron and oxygen. See, boron bond order 1, it shows paramagnetic nature, and oxygen bond order 2, it also shows paramagnetic nature. Except this, all are diamagnetic nature. See, look at helium molecule, bond order 1 diamagnetic, hydrogen molecule, bond order 1 diamagnetic nature, helium molecule, bond order 0 diamagnetic nature, then lithium, beryllium 2 plus ion, bond order 1 diamagnetic nature, and beryllium molecule diamagnetic nature, and carbon bond order 2 diamagnetic nature, nitrogen and carbon 2 minus ion bond order 3 diamagnetic nature, and fluorine molecule oxygen O2 2 minus diamagnetic nature, and neon molecule 0 bond order diamagnetic nature. So this you remember. Generally fractional bond order, it's a paramagnetic nature. Diamagnetic means it shows the only paired electron present in the molecule. Paramagnetic means unpaired electron present in the molecule. Only you know this table, able to answer related to bond order, bond length, bond dissociation energy and magnetic nature in NEET and JEE exams. bond order is increasing, bond length decreasing. Because bond order inversely proportional to the bond length, and bond order increasing, bond dissociation energy also increasing, and stability also increasing. Remember this. Bond order increasing, bond length decreasing. Bond order increasing, bond strength or bond dissociation energy increasing, and stability also increasing. See here, bond dissociation energy. Bond dissociation energy of nitrogen molecule ions N2 So here you know that nitrogen bond order 3, 14, N2 plus. Plus means 1 electron loss here, 2.5. 1 electron gain also 2.5. And N2 2 minus bond order 2. See 3 bond order, you have to apply the more energy in order to break the triple bond. The same way oxygen also. O2 plus bond order 2.5. Oxygen bond order 2, you know that. O2 minus bond order 1.5. O2 2 ions. Here bond order 2.5 to 1.51. This order you should remember that. So now order of the bond length. It's actually this order of bond dissociation energy, order of bond length. Bond order inversely proportional to the bond length. So look at here, bond length 2 is a bond length high. Two minus the same way oxygen O2 minus O2 plus. So here look at here, bond dissociation energy is equal to the stability of bond order. So why here is given N2 plus, here N2 minus? See, remember that always bonding electron molecule is greater than the antibonding electron molecules, and the bond order positive charges is stable, and bond order negative and 0 it's unstable. So here the stability N2 minus N2 plus, so N2 plus is greater than the N2 minus, that is why is written like this. So order of the bond length. So here this is the bond length, you know that single bond length high, double bond length is decreasing, triple bond length is very short. So this order you should remember that. So maximum bond order nitrogen is 3. So now I'm going to solve the previous year NEET and JEE questions. See, look at the previous year questions. Bond order of 1.5 is shown. You know that oxygen bond order 2 and 17 electron bond order 1.5. So O2 minus. The correct bond order of the following species. You know that it's a bond order O2 plus, O2 minus and O2 plus. See here O2 plus 2.5, O2 2 plus 3 and O2 2 plus 3 and here is a bond order 3, it's a 2.5, it is the 1.5. So the answer is C. And which of the following pair species have the same bond order? So cyanide. This B answer, because carbon 6 plus 8 14, bond order 3 and the 8 plus 6 14. This is the answer. Consider the following species: Cn minus, Cn plus, NO and Cn. Which of the following will be highest bond order? You know that the highest bond order is 3. So Cn plus 6 plus 8 14 electrons. So bond order 3. So these are all is less. The pair of the species with the same bond order is, see here is a 3, it is a less bond order, and here is a nitrogen 3, oxygen 2, this is a 2.5, this is less, but same bond order asking. This is the boron 1 and O2 2 minus, that also bond order 1. C answer. Which of the following option represented the correct bond order? Correct bond order, it's a 2.5, 2, this is a 1.5. Here is given opposite. O2 plus is highest bond order here also. So answer is B. According to molecular orbital theory, which of the following lists rank the nitrogen species in terms of increasing the bond order? See, nitrogen is a bond order 3. You see here is nitrogen, here nitrogen given. So the answer either A or B. Both are same bond order 3. We go for the next molecule. Here N2 minus, here N2 2 minus. So N2 minus means half electron. 1 electron is increasing, so 0.5 order. 2 electron means 1 bond order decreasing. So answer is C. This. See, decreasing order of the stability of O2, O2 plus, O2 minus and O2 2 minus ions. See here, look at, you know that O2 plus is a bond order 2.5. You already know that. You check the table also. If you know the table, you're able to answer all the questions. So here O2 plus 2.5, because bond order directly proportional to the stability. So O2 plus 2.5 bond order I, next to 2, and here is a 1.5, here 1. Rest of the answer you see that it's given randomly, not proper order. 4 diatomic species are listed below in different sequence. Which of these represent the correct order of their increasing the bond order? Increasing the bond order. See that C22 minus, carbon 12 electrons, it's a bond order 2, 14 electrons, bond order 3. So here C2 minus is, next is NO, next is the O2 minus, next is the helium. So this is the order. 3, 2.5. Then order is given. Which of the following species is diamagnetic in nature? You know that bond order 1, 0, it's a diamagnetic nature. Here helium plus, bond order fraction. Here also bond order hydrogen 1, this is the 0.5 and this is also 0.5. So the hydrogen is a bond order 1. So this is the answer, diamagnetic nature. According to molecular orbital theory, which of the following statement about the magnetic character bond order is correct regarding to the O2 plus? Here is given bond order, asking the bond order. This is a bond order 2.5. What is that? Paramagnetic nature. So look at paramagnetic bond order less than oxygen. Here 2.5 more than oxygen. So here diamagnetic, that are wrong option. So the right option is B, paramagnetic, and the bond order 2 is greater than the oxygen. Which of the following does not exist on the basis of the molecular orbital theory? Helium. See, when the bond order 0, the molecule does not exist. Generally, what is the helium, beryllium, neon? Do not exist. This molecule bond order is 0. Which of the following has the maximum bond length? See here, bond length they given that. So bond order increasing, bond length is decreasing. This is a 2.5, this is the 2, this is the 1.5, this is the 1. Maximum bond length. The answer is this. This is a 2.5, this is that 2, this is the 1.5, this is the 1. Bond order 1 is a bond length, bond length is minimum, they asked. The bond length is a minimum. So bond order increasing, bond length is decreasing. So O2 plus, this word is given minimum. Which of the following is paramagnetic? See, the oxygen only paramagnetic nature, you know that. Here I want to give one more information regarding the heteroatomic molecules CN, CO and NO plus. These are all diamagnetic nature, but CN is paramagnetic nature. This is the paramagnetic nature. Remember this. So oxygen O2 minus also paramagnetic nature, but CN cyanide also paramagnetic nature. Here cyanide negative ions, this is that carbonyl, this is the nitronium NO plus. So these are all diamagnetic nature. In which of the following pairs of molecular ions both species are not likely to exist? Answer is D, because helium bond order 0 and H2 plus also bond order 0, because it lost 2 electrons. So the answer is D. Here they do not lose the electron completely. Which of the following is a diamagnetic nature? You know the helium plus, H2 plus, O2, oxygen paramagnetic. This bond order is a 0.5, this also 0.5. So these are all paramagnetic nature. Nitrogen is a diamagnetic nature. I hope this you understood this. You are able to answer very easily in the NEET and JEE exam. Only you know the table. Even without know the molecular orbital theory, you are able to answer. Thank you for watching.